Good afternoon. So I introduced you to the concept of phase, the initial phase angle, which you can see inside the trigonometric function sine. Now the later concept to be studied is the concept that if you want to write the kinematics of simple harmonic motion, you come across three equations. First equation that describes the motion is the displacement time equation. The second is velocity time equation. The third is acceleration time equation. These three motions, or trigonometric functions, define different parameters of a body undergoing simple harmonic motion: position, velocity, and acceleration. What is important is how do you understand the graphical representation of the motion. If you see the graph on your right hand side, it represents three trigonometric graphs. The first graph is your cosine graph because it starts from 1. You can see the position of the particle, the starting position at t is equal to 0 is A. The second graph is a velocity graph. You can see that's a sine graph and it starts from 0, which means the velocity is 0 when the body is at extreme position. And the third graph is acceleration graph, just reverse of the displacement time graph is the acceleration time graph. You can see the acceleration time graph is also a cosine function but is inverted. Now let's introduce the concept of phase here. If you can see the third picture, you can see the position of one body is represented by x1, the position of the second body is represented by x2. If you subtract the angle inside the trigonometric function, which is omega t and omega t minus pi by 2, you will be left with pi by 2. So that represents the phase difference. So remember, there is something called as phase and there is something called as phase difference. Thank you.